Hello everybody and welcome to Practical Power Electronics episode 5. In this episode we study small flyback converter waveforms. Simple basic flyback converter, and a schematic is like this one. We have primary side supply voltage is 24 volt. We measure drain voltage, which is this point, or between those points, and we measure fed current with shunt resistor, which is this one. Secondary side, we have two windings and two outputs, plus 15 volt and minus 15 volt, and our load is so that the current is 0.5 amps. So in that case it's 30 ohm. And we measure also this current over here. So Flyback operates discontinuous conduction mode, and I think that's all. Let's make a measurements. Here we can see the test setup. This is the flyback converter. This is primary current measurement, fed drain voltage, secondary current measurement in plus 15 volt side, and double load. And this meter shows about 500 milliamps, half amps current, and input voltage is 24 volts. So this small flyback is producing about 15 watts output power, plus 15 volt and minus 15 volt, and input voltage is 24 volts. Here we can see voltage and current waveforms. Channel 1 is primary fed current, which rises up linearly about 4 amps, and channel 3 is plus 15 volt secondary side current, which slopes down linearly. So in this mode, flyback is in discontinuous conduction mode, which means that First we charge magnetic flux in air gap, and after that we discharge it completely. So after discharging there is no magnetic flux and energy in air gap left anymore. Here we can see drain voltage, primary side drain voltage. And here it's near 0, and during this time the input voltage 24 volts is across the primary winding, and this FET goes off. We have high voltage spike, which is about 100, little bit less than 150 volts, and it goes down here, which is input voltage plus the voltage which is generated from the secondary side to primary side. And it stays here a little bit over 50 volt until the secondary current goes 0, and then it goes back 24 volts, but it oscillates around this 24 volts, and next cycle start FET goes on again. This big voltage spike is because of leakage inductance in primary side, and it is snubbered with RC snubber. Otherwise it would go much higher, and with it also could oscillate much more. Now it's dumped. Okay, let's take some screenshots. I press the save button. This picture, this is good. Also this is good. Oh, and the switching frequency is about 118 kilohertz. Okay, the measurement is done. Here we have the test results. This one here is primary current, which is measured here, shunt resistor, and we can see it ramps up until it's reached value about 4 amps. We can calculate what is primary inductance of flyback transformer, which is this is the basic equation, and we solve this inductance L. We have 24 volts, and the YDT is 4 amps divided by Okay, how much is this? This is 5 microseconds per div. It's about 3 microseconds. It's about 18 micro volt second per amp, which is 18 microhenries. We can also calculate primary power. Primary power can be calculated. We have to first calculate what is the energy stored in the inductance, which is like this one, half times L inductance and current squared, which is this case is which is 144 microjoules, and P in is, we have switching frequency 119 kilohertz times this 144 microjoule. Which is 17.1 watt. Okay, it makes sense because output power was about 15 watts. Plus 15 volt and 0.5 amps. 7.5 watts and 7.5 watts here. So about here, so we can see here we store energy, which is maximum here, which was this 144 microjoules. And after that we discharge it to secondary side. And after that storage energy is 0 and cycle starts all over again and repeats itself. And this voltage spike here is because we have here small extra leakage inductance, and when the current cuts off, it not transfer to secondary side immediately. This stored energy here have to go somewhere, and this leakage inductance rises the voltage until it's find a way to push the current. So in this case we have here snubber, RC snubber, like this one, and this energy goes, these capacitors through this resistor. And that's why we can see this kind of waveform. Okay. We can estimate efficiency if we have 15 watt output power and 17 and 1.1 watt input power, which means about 0.87%. Of course, this is very inaccurate, but we can calculate it for fun. Okay, that's all this time. Thank you for watching and see you in the next video. Bye bye.